Hello, everyone. On behalf of the entire team here, I would like to say thank you for taking your valuable time to join us for today's webcast, How to Make Database Changes Easier for Application Developers. My name is Robert Reeves. I am one of the co-founders and the CTO for Datical. I have a few comments about today's webcast before we get started. First, please note that all attendees have joined in listen mode only. You can hear us, but we are not able to hear you. That doesn't mean we don't want to. We certainly do. If you have any questions throughout today's presentation, you will be able to ask them. Simply type them into the questions section at the bottom of your webinar control panel, and we'll do Q&A at the end of the presentation. Look, you have questions during the presentation, go ahead and type them in, and you'll be top of the list when we get to that section. Finally, please note that we are recording today's webinar, and we'll send out a link to that to all the attendees. So now we are ready to start our presentation. Here to explain how to make database changes easier for application developers is Datical's other co-founder and Vice President of Products, Pete Pickerel. Take it away, Pete.
Thank you, Robert, and good morning, good afternoon, good evening to you, based wherever you are in the world. Thanks for joining us today. We're going to talk a little bit about what Datical is the passion at the core of Datical, which is making database change easier for everybody, but specifically how you should be able to do that for the developers as well. Just to give you an overview of today's content, I'll spend just a couple of minutes sort of establishing the lay of the land as Datical sees it from our independent market research and interviews with our customers, and just our experiences over the last several years implementing DevOps for the database at companies large and small. After that, I'll give you some nice general pointers that our other customers have used to bring the database change process more in line with the application change process, making it easier for everybody, but especially the developers. And then I'll spend just a minute at the end kind of detailing some features in our 4.0 release, which came out just a few weeks ago, that sort of serve the points that I'm going to make about streamlining the database change management process. We've built some nice automation and workflow support around these ideas that we developed in conjunction with customers and have been using to great effect and teams of all sizes. So to start out, as many of you already know, the processes and the tools available to application developers have advanced exponentially over the last 10, 15, 20 years. There have been regular and dramatic advancements in automation for, developing applications, testing applications, and releasing applications. And movements like Agile and DevOps have sprung up to sort of centralize the conversation and establish some tried and true patterns that can be implemented at any company to improve their application development processes. So with all these advancements, they've kind of combined to provide a steady, ongoing push towards improvement of that delivery lifecycle. It's enabled faster, easier application development, and it's ultimately resulted in better quality software. But when we first started Datical, we went on a multi-month market validation campaign where we surveyed, hundreds of people in IT and companies of all verticals, all shapes, and all sizes. And out of that research, what we found was that every time you update the application, 4 out of 5 times that you update the application, there's a database change associated with that. And that's putting it simply. When you talk to the DBAs about those changes, it's really every application change needs to be taken, the database aspect of it needs to be taken into consideration. But a lot of the automation and the movements like Agile and DevOps haven't really made its way down to database change management yet. So we're still managing our database change and updating our databases a lot like we did, in the late 90s. So it's still a very manual process. In some of the companies we go to, we see that they'll have a 2-day SLA for any sort of database change in support of the application, because it is a manual process. A DBA has to take that script, has to review it, and has to approve it or deny it. And if he approves it, he or she usually applies it to the test environment that was targeted by the change request. So if you look at a 2-day SLA in the context of a 2-week sprint, which is 10 working days, you're looking at, 20% of your sprint time is waiting on a single database change. So if you have multiple database changes in that same sprint, you could spend a lot of that development time waiting for those changes to come through. And unfortunately, state of the world now, that's a very necessary exercise. The DBAs are on the hook for maintaining the safety, the security, and the availability of that data platform. It's a very risky endeavor to update the database, much more risky than updating the application, because one mistake can bring down all of your applications, can bring down the database, bring down all of your applications, or it can open a security exploit that allows people to get in there and grab the data that really shouldn't. And at the end of the day, keeping that data secure and complete, not losing any of it, is really, that data is the lifeblood of your company. It's what you base all of your, strategic development decisions on. It's how you extend new products and services to your customer, and it's how you prove to your board or the public, how well your company's faring. That data is used for a lot of purposes. So because it's a manual process for one update, and it's a really risky process that must be observed, it's very resource intensive, especially as, all of the advances in the application development area I was referencing earlier have accelerated the velocity of release. So now what you have is this resource intensive process. You've got, a back and forth between DBAs and developers. Those changes are coming in more frequently, more fast, and with much more urgency than they ever have before. So DBAs are really feeling the pinch. They haven't had the same level of process development or automated tool chain evolution that their brothers in application development have. So they're still working in a very manual process in a very automated world. So how can we make database change safe and fast and kind of match the pace of application development? And really, you don't have to reinvent the wheel here, because we can take the success that application development has had in updating their tool chains, in formalizing their processes, and really developing this streamlined workflow from source code control through various levels of test automation to production value realization, and apply that to the database. Now, the database, there are some special concerns when you're dealing with the database. Obviously, it's a persistent store. It's not as easy to rip and replace as an application. Unwinding a database change is equally as manually, and if not more risky than it was in applying it in the first place. So there are a few special considerations you have to make about the database, but it is possible to map that process much more closely to the great success that's being experienced in application development. So really, at the end of the day, we're working towards continuous integration of these database changes. So continuous integration, a lot of you probably have heard the term before, but if you haven't, it's the idea that when an application change is ready, it's automatically built in context of the larger application to make sure that it is playing nicely with other changes, that it's going to work in the larger context of the application, and to really, all of it's done in an automated fashion to really give developers quick, concise, and useful feedback on whether they are truly done with that change or not. So we need to kind of bring that same pattern to the database. So database changes, there's no reason with the tools and the established processes in place today, there's no reason the database changes shouldn't be frequently, automatically, and consistently validated, integrated, and packaged for reliable downstream deployment. It's really about getting those database changes out of application development or from your database developers, working them through a similar automated process that is used to validate the application changes, and providing that quick feedback, all while reducing the burden on the DBA to provide that, the manual touch for every single change that goes through the process. Because what we've heard from our customers and what we've heard from the market is, they have to check every single script and every single change. Although 90% of them are pretty straightforward and safe, they still have that overhead of receiving the ticket or the change request, processing that change request, approving it, and moving it on. So if there's any way to automate away those 90% and really just call the DBA's attention to the roughly 10% of changes that absolutely need their direct attention because of their expertise and their knowledge. We're going to save these guys a ton of time in their day-to-day to concentrate on more strategic activities like capacity planning and security and investigating new platforms, some of the semi-structured stuff that is the new hotness and all the rage in the conference circles, to really just kind of, get ahead of those and figure out how those are going to impact their world and how they're going to be a part of managing it and staying on top of the company's wider data strategy. So there are, 4 primary points, 4 primary things we can do today to start integrating that process, the database change process, into the application change process. And the first thing we want to do is trade that file share and ticketing system for source code control. Source code control is, I don't know, it's like the combustion engine for application development. I think that the invention and use of source code control has really accelerated application development more than a lot of other things. Because before, application development looked a lot like database development does today. You would put files on a file system, you'd have to run them through a compiler locally and do your own test to make sure your changes were right. You were constantly clobbering each other as these files were overwritten and changes were overwritten. You're having to pull those changes apart. And you never really, outside of code comments, which not all developers are as conscientious about as they should be because they're very busy, you didn't really have a history of how that file, that feature, that function came into being. And that's kind of what we have in the database space today. Database changes are usually managed, a script is uploaded to a file server and a ticket is sent through ServiceNow or some other sort of requesting ticketing system to a DBA. They go get that script, they read it through, they run it in their system, and they say yes or no. And really, the only record you have of that passing is in that ticketing system. But that ticketing system is used for a lot of things, and unless you're super conscientious about your labels and your queries to pull information out of that, it's really hard to, A, put all the moving parts of your application schema together in context to review as part of the larger whole to see what the database impact was of a specific feature or release. And B, it's really hard to collaborate with other people on developing those changes. So source code control, the commit message system will contain all of that meta information, like, this is in support of this business requirement, this JIRA ticket, this is what I did. It gives you the developer who worked on it and checked it in. You really just kind of develop this living history of, the SQL scripts you use to update your application over time as they're developed. And it also unifies the workflow. So now, the database changes are now entering the system at the same point the code changes to. And this opens you up for a lot of, sort of future expansion and development of your process, getting it, bringing that database change process into the same tool chain, into the same process that you're currently using in application development by escorting it in through the same door. Because these things integrate really, really nicely with, the existing build tools, the existing release automation tools, and you've also got your source code changes. You're checking in your database code changes in the same place you're checking in your source code changes, and you're able to keep everything sort of aligned and organized and easily referenceable as it flows through a much faster system. So this next one, automate SQL script validation. This is a hot topic. When we are working with customers and talking about the validation automation, they get very concerned that things are just going to be flying through a system with automated checks that they don't really understand or may not be comprehensive. So the automated SQL script validation isn't intended to replace the expertise of a crack DBA who has kept your application up and running and your platform performant for the last 15 years. What it's really meant to do is reduce the amount of hay around the needle. I mean, it's very easy using a tool like Sonar or some other static analysis tool, which if you Google SQL static analysis, you'll see there are several plugins you can use in a solution like Sonar to find a lot of low-hanging fruit. And it's very easy to kind of, reduce the amount of things that the DBAs have to look for in a script or the number of scripts a DBA has to look at by implementing just sort of the checks around this low-hanging fruit and either doing it, manually when a batch of scripts are ready or as part of the automated build system. But what this is going to allow to do is changes kind of fly through the system faster. If you're taking care of a lot of those really, the low-hanging fruit checks in automation, you're going to be consistently enforcing those rules. And then what you can do is write rules that don't say yes or no, but provide information like, oh, this SQL script contains a grant statement. DBA, come look here, you need to review this grant statement. So it's really just kind of a canary in a coal mine technique of finding the scripts and the changes that might have undesirable impacts on the overall application infrastructure. So it's not so much about replacing the valuable contributions of DBAs. It's about letting them really focus in on the problems that need their attention instead of just backing up the truck and dumping script after script on them that they have to read through before they execute. So once you have sort of these initial automated scans of your SQL code implemented in a tool like Sonar, or even some of the IDEs have it integrated. I know that Dell Software's Toad has a really nice suite of checks it does when you go to commit a new piece of database code, and it won't let you check in that code if it fails any of those tests. There are options out there for you to use to really start programmatically assessing some of the quality standards around your SQL scripts. And then once you have that built into the process, just like the source code control contribution, you can bake that into a solution like Jenkins or Urban Code Deploy or CA Nolio or whatever your build system is, your build and release system is. You can build that automatically into the process, so it happens every time one of those changes comes into being. So this one is sort of a concept of continuous integration that we really sort of put out in front of the DBAs and the application developers we work with early. And it's the concept of a reference environment. So what we've learned through market validation and through working with our customers is that, database developers develop changes in a myriad of ways. Sometimes it is in a very tightly controlled environment that several developers use, so that as they introduce stuff to the application schema, they get ahead of those sort of collisions, and that's great. That's the best case when your company is using a single database to sort of integrate all the various changes that are being made in order to get ahead of the collisions and the problems that might be caused by concurrent development. You're doing really, really great. But then we see other places where developers have their own sandbox, and they might use a diff tool to generate a change script from that sandbox, but the sandbox is the Wild West. There's all sorts of what we call space trash, but it's tables from 3, 4, 5 releases ago that you renamed 5 different iterations of before you landed on the last table. They may not be up to date with the latest indexes applied to production for performance reasons. So there's really just not a lot of fidelity between what's in those dev sandboxes and what's in your staging and production environments. And this leads to trouble. It may not lead to a production outage, but as that change, as your changes leave that dev sandbox and go into downstream environments, you may run into collisions. And even then, you're delaying application development. You're delaying application testing because what you've done is sort of left the database in a half updated and broken state that needs to be manually addressed and resolved. So we recommend that, if you don't currently have a reference database, an integration database, where all of your developers are contributing their changes, that's the first best step, is to keep that database as refreshed with production or stage as possible, and to keep it locked down as tightly as possible. And if you implement some of the other automation strategies we've talked about, like putting your SQL scripts in source code control, you can keep it locked down and just have those scripts run on the database as part of the application build. It allows not only one team to develop across what they're doing for their release, but if you have multiple concurrent pipelines of development, you always have a peek into what's going on in previous releases, so you can appropriately plan for future releases. So once you've taken care of those 3 steps, the best thing to do is to integrate the automation with your application build. And this is where you really start to reap the rewards of modernizing your database change process, because developers are no longer tied to that 2-day SLA. They can get ahead of a lot of the the manual checks through this automated build process and know, okay, at least for the low-hanging stuff, I'm not doing anything that's easy to detect or boneheaded. This is going to go through the environment. It's going to play nicely with other changes, and they get pretty much immediate feedback after that application build and test session to that their changes are going to be accepted and are going to move forward. So then that validation that you've built in is sort of the cornerstone of that. So, and what we've seen with our customers is they'll start with a very simple set of rules, and then they'll extend that into deeper areas, and eventually they get to the point where they most of the changes do fly through the system in an automated fashion. They have one review point where there are very few surprises because the automation has really captured a lot of the issues that they've encountered. So it's great to get the initial set of rules in place, but you always want to be constantly evolving those rules to change, to fit your changing business needs. And they need to be, you need to be able to write those rules yourself because, what your standards and best practices are may not be the standards and best practices of the industry. So you need that fine-tuned customizability of that rule set. And then the best part of it, as Robert, my co-founder, the guy who introduced me, likes to say, there are two things that get a developer's attention more than anything. The first one is free food in the break room, and the second one is you broke the build. So by automating this fully, not only are you getting them feedback quicker, you're also empowering database changes, bad database changes to break the build, which gets attention like nobody's business and really kind of helps train your developers on what an acceptable change is so they avoid that process. Those are sort of our 4 key tips on how to make database changes easier for application developers by sort of mimicking the patterns in place with them. And in Datical DB 4.0, we introduced a feature called the deployment packager that takes a lot of this into consideration. So this is a very simplistic drawing of what the deployment packager probably is, but I think it sort of conveys the key points. So the funnel on the left represents your source code control system. So as scripts are developed, those just get checked into source code control. And because we've implemented the automation portion of this, that will kick off automatically a build where those scripts are pulled out, and based on the commit messages for source code control, we can apply labels to them to tie them to specific features and releases, really just kind of make all of these changes cohesive as the same package. That's where it gets the name. We're really just creating a package we can then push to downstream environments in support of a specific release or application feature. But the process it flows through is, first, Datical has the infrastructure to write customized rules on SQL scripts and on the object model that Datical uses to affect change in your database. But basically, we take the SQL scripts as they're contributed, we scan them for just sort of obvious things we can ping on and find as problems or areas that need more investigation. We'll then reverse engineer those scripts into the Datical object model, and by putting it in that object model, we can not only validate the script changes itself, we can also take that in context of the larger database model and make sure that there aren't going to be any conflicts or you're not violating any rules about or best practices around data types or naming conventions or things of that nature. So we've got that multi-phase automated change validation that really frees up the DBAs to concentrate only on those things that matter most. We also manage that reference DB environment for you. So if you do run into an issue with a change and it gets half updated, but it violates a rule, we're able to return to the previously known good state of that operating environment. And it's tightly integrated with source code control. So, once the changes are brought into our object model, that object model is also updated in the same source code control system used for your application code. You can even upload it to an artifact repository like Artifactory or Nexus, and really just kind of push it up in there, pull it out as part of your application build automation, and deploy in much the same way that you're deploying these application changes. So with the deployment packager, we're really just kind of matching up to what development has already built and has proven works. So we eliminate the back and forth between the dev and the DBA by automating most of those changes away. We integrate with the tools and processes already in use by application development and operations to build, test, and release your applications. And the automated deployment capability makes it, you're no longer on that conference bridge for 36 hours waiting for something to go wrong. That's handled in source code control. It's handled through sort of predictive analysis of the changes that is available in DB. So when you get to that deployment step, it's really just an automated non-event because you know it's gone through several layers of automated and manual review. And what that ends up with is an application development process that is more tightly aligned, that is using the same tools, is using the same terminology, is using the same processes. And it allows you to respond faster to business needs. It allows you to protect better by making sure that your DBAs are focusing in on the crucially important aspects of protecting your data store, your data environment, your platform, and spend less time reading create table statements and looking for default values, because that's the kind of thing you can automate away with DB. And because everybody is rowing in the same direction, we've removed a lot of the manual static in the process of updating the database. Everybody's performing higher. We're closing that deployment gap between application development and database deployment. So at this point, I know that I ran a little long, which I tend to do. I love to talk. We do have a few minutes for questions, Robert. So if anything came in over the wire, now would be a good time to address those.
Okay. Thanks, guys, for submitting all those questions. I'm scanning them right now, and we've got one on rules. Do you provide any rules to get customers started? Or is it possible to write your own rules?
Okay, yes and yes. So we through our work with our customers and through our own research, we've developed a suite of rules that every customer can start with. But what Datical is, we don't just sell you software. We view ourselves as shipmates on your voyage to better deployment practices. So we're right there with you. We implement that reference project with you. And what we'll do is, part of every implementation, one of our first questions is, what are the 10 things you wish you didn't have to look for in SQL scripts anymore every time one comes across your desk? And we'll help you write those first rules. So you've got sort of the library of rules that we already provide, and then we custom tailor a few rules for you so we can get you comfortable with the process of writing your own rules, because that's where the validation really becomes interesting, is when you are writing rules to check for things and confirm things that are specific to your work, your job, your business. That high level of customizability is where you really get a lot of value out of the automation that Datical provides. Good question.
And we got a lot of questions here. So for those of you that we don't get around to answering, we're going to send you an email to make sure your question gets answered, because we want to be respectful of the time limit here. We're going to stop at the bottom of the hour. Does Datical require dedicated hardware?
No. One of my favorite things about Datical, how we built it, is we do have a UI, but that's really mostly for demo purposes. What'll end up happening is a Datical installation will just kind of meld into the automated build infrastructure you already have. So there's no hardline requirement for Datical must be on its own server. You've got to open up these ports. It's got to be able to connect to, a single instance of Datical needs to be able to connect to all the databases in your pipeline. It's really very flexible. We share, because we use source code control to share the project artifacts, it's really a matter of having individual installations of a Datical engine where it's needed most. So you will have one in your dev and test data center, you'll have one in your production data center, and then the Datical artifacts are just sort of shared in those two locations and fed through the engine in order to do all the validation and affect change. So there's not really any specific. Obviously, you have to install it somewhere, but there's no specific requirement for a server, and there's definitely no requirement for installing an agent on every single database you own, because as veterans in the IT space, we know how very, very problematic that becomes to manage.
Okay, we're going to ask one more. Do you support Azure databases? But I guess, Pete, you could talk about the databases we support.
Oh, okay. Yeah. So we support Oracle, we support DB2, we do support SQL Server, and a part of our test infrastructure is Azure SQL Server. So we do have support in that arena. Really, our connection and interaction with the database is based on JDBC, the Java Database Connectivity standard. So really, we just need to be able to access a JDBC port and have appropriate credentials to connect to that database, interrogate it, and affect change there. But it's Oracle, DB2, SQL Server, and we do test in Azure as well.
Okay. And we had one last question that I do want to answer because it's funny.
Okay.
The question was, I missed it. Arr!
Well, if you missed it, we are recording this. We're recording this webinar, and we'll send a link out after this once we get it posted somewhere that you can review it. So you will get to see it. Fear not. We've thought of the stragglers. We know how busy people get and how it's kind of hard to dial into webinars sometimes.
Yeah, we got your back, yo. But for sure, guys, look, you're desperately busy, all right? And we get it. And that's, you know, that's why Pete and the team built this product. We understand. We get it. So reach out to us. Let us know. We certainly have a companion white paper that's going to go along with this. You know, go ahead and visit us at datical.com. You know, Pete is also a very prolific tweeter, so you should follow him.
As is Robert. Robert tweets too. He is at Robert Reeves. I am at Pete Pickerel, and we really love the anonymous attention of social media. So if you can follow us, that'd be great. And Datical. Oh, Datical has a Twitter as well.
Oh, we do.
At Datical. Yeah.
I
want to follow
forget
at Datical.
I always forget that. All right, guys. Hey, look, I hope you have a great day. Thanks for joining us. We'll see you real soon. Take care.
Thanks, folks.